Okay, I'll just take attendance first and then we'll start off. Please answer your attendance. Karan, Alan,
Present, ma'am.
Subhashram,
Present, ma'am.
Richin,
Present, ma'am.
Tom,
Present, ma'am.
Anthony,
Present, ma'am.
David,
Present, ma'am.
Calvin,
Present, ma'am. Present, ma'am.
Ryan,
Present, ma'am.
Astel,
Present, ma'am.
Jacob,
Present, ma'am.
Ebbins,
Present, ma'am.
Praveen,
Present, ma'am.
Vishnu,
Present, ma'am.
Jerry, Daniel, Prashant, Mukesh,
Present, ma'am.
Ashwin,
Present, ma'am.
Rohit, Abhikash, Tarun,
Present, ma'am.
that was Tarun or Abhikash?
Rohit Apika is also present,
Ma'am,
ma'am.
Rohit is present, ma'am.
Rohit typed in chat box.
Okay. Tarun, Sam,
Present, ma'am.
Sri Ram,
Present, ma'am.
Arun,
Present, ma'am.
Siol,
Present, ma'am.
Jason,
Present, ma'am.
Kristen,
Present, ma'am.
Akash, Febin,
Present, ma'am.
Mohammed,
Present, ma'am.
Alex, Sam,
Present, ma'am.
Ajay,
Present, ma'am.
Jeffrey,
Present, ma'am.
Deepak.
Present,
Sorry,
ma'am.
present, ma'am.
Okay. Sushil, Joel, Richard,
Present, ma'am.
Gibson, Mithun.
Ma'am, Joel typed in the chat box, ma'am.
Okay. Gibson,
Present, ma'am. Ma'am.
Mithun,
Present, ma'am.
Gibson Sam,
Yes, ma'am.
Vara Teja,
Present, ma'am.
Aditya,
Here, ma'am.
Aditya. Okay. So absentees are UL 1, 15, 16, 21, 28, 32, and 41. So today we'll be starting a new unit. Okay, shear force diagram and bending moment. So whatever I teach till Friday will come for your internals. Okay, so that's what we're gonna do. So I'm just going to share my screen now. So tomorrow's class, the next class onwards, I will start using my iPad. Okay. All right. So the first, this unit is known as shear force diagram and bending moment diagram. What do you mean by that? Is first of all we learn about different types of beams. Okay, and when you apply load on that particular beam, all right, you need to calculate. If there is a beam like this, you need to calculate on every point how much is the shear force because of that load. Okay, so the shear force and bending moment will vary across the beam. For example, okay, if this is the beam, you apply load, what will happen? Will it bend? Can someone respond? Will it bend if I apply load from top? Guys, please switch on your videos. Everybody. Switch on your videos. Use the chat box or unmute and give the answers, because in between we are starting. This is a very important topic. I don't want all of you to sleep. Switch on your videos, everybody. So what will happen if you apply load from the top? What happens to the beam? Will it bend?
Yes, ma'am.
So if I draw a beam here, for example, okay, and I apply load here, how do you think the beam, is it going to move down like this? And there's a support here. If there's no support, what will happen to the beam? It will just directly move in this direction. Okay, but if there is a support, what will happen to the beam? The beam is going to bend like this. Oh, my diagram. Okay, the beam is going to bend like this. That means if I take this a line here, the bend is maximum where the load is acting, and then here it decreases, and finally at the support it is 0. So at here the bending moment is maximum. So if you notice here, there is the bending moment is varying. Okay, I'll just draw a better diagram. The beam is going to bend like this. Okay, the bending moment is varying on the throughout the length of the beam. Okay, so we will be calculating the bending moment at each point and shear force, and we'll be drawing a diagram, okay, a graph on it. So before we go ahead, you need to understand how to calculate reaction forces. I think in engineering mechanics we have learned how to calculate reaction forces. Have we done that last year? Guys, what happened to the videos? Everything is off. Bharateja,
Ma'am, could you see my video, ma'am?
Richard, I'm not able to see yours actually.
Ma'am, but my
Someone?
webcam is on, ma'am. Some antivirus issues, ma'am.
Okay,
I'll
okay.
check on that.
Yeah.
Yesterday I installed a new one, so
Okay.
I'll
You can
check.
just answer the questions, guys. Those whose videos are off, I need you to at least unmute and talk. So have you done this in engineering mechanics, how to calculate the support reactions? Yes, no? You guys are... Okay, Joel remembers.
Yes, ma'am.
You Richard also remembers. Nathaniel, what about you? You joined late the semester, right? Bharateja also says yes. No. Richin. Okay, so let's go. Today's class, we will just do a recap for the benefit of those who haven't. I expect all of you to switch on your videos because this is going to be an interactive class. It's not just one side. If you're not able to switch on your videos, please unmute and answer or use a chat box. Type something. Okay. So we'll be learning about different types of beams and different types of loads. Okay, so all of you know what a beam is. It's a long, straight, prismatic member. Okay, subject to forces perpendicular to the axis of the beam. So this is something that you should assume. Okay, there is the axis of the beam in the middle. The load is acting perpendicular to that axis. Okay, so that such members are known as beams. So where is exactly it is used? You know, this is a very common example. Beams are mainly used for construction. In mechanical, axle of a car is considered as a simply supported beam. Okay, different types of machineries. shafts of machineries are also termed as beams of different cross section. This is all right. This is also of different cross section. Okay. Coming to equations of static equilibrium, you guys know this. We have done it in engineering mechanics last year. So equilibrium of a body in space. If you say that the body is at equilibrium, that means if you apply force, okay, uh, it remains there is no movement, okay. Or if a body is moving in a particular velocity, and if you apply force, nothing happens to it, okay. That means the body is at equilibrium. So static equilibrium means the body is stationary. If it is moving, that is dynamic equilibrium, okay. So for static equilibrium, these are the 6 equations which will be equal to 0. All the forces in horizontal direction, summation of all the forces in horizontal direction equal to 0. All the forces in vertical direction equal to 0. All the forces in in z direction equal to 0. Similarly, moment about any point in the direction of x equal to 0, y, and sigma mz equal to 0. So you guys know this. This we have already taught. I have already taught this last year. Types of support. You have roller support, hinge support, fixed support. Okay. So we learned till now what is a beam and what is static equilibrium. The next topic is types of support. So what do you mean by roller support? There is a roller here. So the beam can roll over this. Okay. But the movement in z direction is restricted. All right. So RA, there will be a reaction force. So whichever direction it is restricted, there will be a reaction force. So this particular arrangement, there is only one reaction force. Okay. That is this direction is, but the body can move, the beam can move in this direction. It can move to and fro. Okay. So these are the graphical, uh, you know, schematic diagram representation of the roller support, a triangle and 2 rollers, or just a circle. Okay. And this is an inclined. Okay. So your reaction force will always be perpendicular to the surface. Okay. Here also the reaction force is going to be like this, not like this. Okay. So it is capable of resisting force only in one specific direction. Okay. Next, these are the types of roller supports that we have. Here it's a roller support, hinge support. Okay. It is resisting force in any direction of the plane. Got it? So that means in y direction also the beam can't move up and down. The beam can't move right side and left side. So in x direction it is restricted, y direction is restricted. So there are 2 reaction forces for a hinge support. And fixed support, it is completely fixed. See, this is a hinge support. Okay. Here it is completely fixed. So there will be 2 reaction forces and 1 moment. It's resisting a moment and a force. So if you apply force here, so there is an equal and opposite force, Fv, and this particular beam is going to bend like this. Okay. So there will be a moment in this direction. So there is an equal and opposite moment at the support. Clear? Are you guys clear? So we learned about beams, we learned about static equilibrium and types of support. Let's go ahead with the types of beams. So we've got cantilever. So we'll be solving problems on under cantilever and simply supported beams. Propped cantilever is also there, of course, and overhanging also we'll be solving problems. Fixed beams and continuous beams are also available. So you all know what is a cantilever. It is fixed on one end and this is a free end. Got it? There is no support here at all. So that's a cantilever beam. Propped cantilever is when you have, see in this one, there is a support at the end and you have a load acting on it. Okay. Next is simply supported. You've got hinge support. You can have both sides hinge support. You can have both sides roller support. Okay. But on both the ends, there will be some support. That is called a freely supported beam or simply supported beam. So it's called as either freely supported beam, simply supported beam, or freely supported beam. So you'll have two reaction force here and here. In this, you'll have only one reaction force. Okay, so we name that as RB. Y. Here it is R A Y and R A X. Clear? Overhanging, you have a hinge support or a roller support, and it overhangs the support on either sides. Either it can be either sides or just one side. Clear? This is a fixed beam, fixed on both the ends. For a cantilever beam, it is fixed only on one side. Fixed beam, it will be fixed on both the ends. Continuous beam, okay, you have number of supports. It's a simply supported here, again it's a simply supported here. So it's a continuous beam. Clear? So how many types will we see? Cantilever, propped cantilever, simply supported beam, overhanging beam, okay, fixed beam, continuous beam. Now the last part that we have to learn is types of loads. So we'll be solving two types, okay, as per your syllabus. Concentrated or point loads, uniformly distributed load. But I'll also tell you what is varying load and a moment. Okay, concentrated load. Okay, now if you have a pole here, it's a building, imagine it's a building, there's a window here, okay, or it's a bridge probably. Okay, let's take it as a bridge because it's simply supported. You have a so if it is a fixed end here, not fixed, it's a hinge support at A and B. So you have reaction forces RAY and RAX. You've got an extra weight which is acting downwards. So you have to show it like this. So it's a point load. Okay, you have a pillar here. So the weight of the pillar will also be a point load. So P. Okay. Similarly, there's another weight load here. So at this point, it will be R. And you've got they have shown only one. That means it must be a roller support. Okay. So this is the actual drawing. Actual. Okay. And this one is the idealized. That means the free body diagram. Okay. All of us have learned what is free body diagram last year. So this is known as the free body diagram. So all these forces, these loads will act at a point. So it's a point load. Uniformly distributed is, imagine there is a tank on top of your building. Okay, it is filled with water. So the weight of the tank, okay, so this is the weight of the tank, it is acting throughout the beam. Okay, so you can denote it like this. And the weight of the water is also acting throughout the beam. You getting it? Okay, the reason why we're taking it throughout, because the thickness of the wall is going to be very small. It's going to be very less. So that's why it's taken as throughout the beam. So this is known as uniformly distributed load. Okay, this is the actual and this is idealized. Are you guys clear? Is this clear? What is a point load and what is a uniformly distributed load? Yes, no?
Yes, ma'am.
Yes, ma'am.
Okay. So this is another type of uniformly distributed load. The beam, weight of the beam can be like this. Okay, weight of the beam. And this is, the goods are there on this side. So uniformly distributed load of goods plus the weight of the beam. Okay, so this is the weight of the goods. This is known as a varying load. For example, if you have a dam, okay, you've got a dam. How does a dam look like? Something like this. Okay, and you've got water. Okay, so this is the water. The dam is always, why is it that dams are created like this, built like this? More material here, and then it reduces. Why?
The pressure increases as we go deeper.
Yeah, the pressure increases as we go deeper. So this is showing the hydrostatic loading, the pressure of the load. Okay, hydrostatic loading. So the pressure here is more. So this is known as a uniformly varying load. Got it? Okay, so basically the dam is constructed in such a way that it can withstand that pressure. If you have it same, automatically this portion will rupture. Okay, so hydrostatic, so this is a varying load. Similarly, this is also a type of a varying load. Okay, yeah, all right. What is a moment or a couple? This again, you know it because we have learned it in engineering mechanics. I'm not going to get into details. System of two forces, equal and opposite, equal and opposite, magnitude, parallel lines of action and opposite in sense. Okay, will create a couple, a rotating force basically. Okay, so you can easily calculate. So if there is a load, see if this is a beam and you have a load, and the load is not acting like this, it is acting on this part of the beam. Okay, so it will create a moment, W into D. So this is a moment or a couple, actual and idealized. Clear? Clear about this? Can someone tell me what are the different types of supports we learned?
Ma'am, roller support, fixed and hinge. Fixed support and hinge.
And hinge support. Okay, and I think you guys can just take a screenshot and write it down in your notes. Anyway, I will be sharing the PPT. Okay, but I just want you to draw only this diagram because we will be using this in the problems. Okay, write types of supports, draw this diagram, or maybe you can draw this diagram alone. Okay, only this one diagram, and write the reaction force RA. Switch on your video so I can know when you guys are done. I'll show the next slide.
And should we try to take screenshot here?
What?
Just write or should we take screenshot?
You can write it because if you take screenshot, I don't know whether you'll be able to refer to it while we do problems. Just write it in your notebook. I hope you have a separate notebook for the subject.
Yes, ma'am.
Yeah. So just write it on that. And I had also told you guys to do the principal stresses and strains. I have not uploaded it. I'll upload it. By end of this week, I want the assignment. Okay. And you can draw it in your notebooks itself. Just take a screenshot, convert that into PDF and submit. Okay. I think you must be done. No need to write the definitions,
Yes, ma'am.
just draw the diagram. In support, draw this diagram. Done?
Yes, ma'am.
Last one. All right, I think you must be done. Okay, so if there's no need to write, we'll anyway be doing it. Loads. So we have like 5 minutes. All right, this also I will teach you. So finding reaction in supports. Okay, so if you have a cantilever beam, okay, pay attention. I'm just taking class for another 5 minutes, but this is important. You have load at the on this side, the free end, W. So what will be the reaction forces here? First of all, there will be an equal and opposite force, F. Okay. So I'm going to denote reaction forces R. Okay, RA. I got 1 minute. RA. Okay, let's take it as RAY. And there will also be a, because it's a fixed support, there will also be a horizontal force, X. Okay, and because this will bend, okay, there's going to be a moment in this direction. So there's going to be a moment in the opposite direction. I'm going to take it as MA. Okay, why MA? Moment with respect to A. All right, so you have a vertical force and the horizontal force is not there. I'll tell you why. And so what will be the value of our AV is what is finding reactions and supports. How do you find that? We use the equations of equilibrium. Sigma V equal to 0, sigma H equal to 0, sigma M equal to 0. So sigma V is going to be, what are the vertical forces we have? RAV and W. So let's consider all the sign convention as upward force is positive, downward force is negative. Here they are taking clockwise direction as positive, anti-clockwise as negative. Okay, so if we take this, W is equal to RAV. So what is the value of RAV? It will be W. That is the reaction force. Got it? And what about if you take sigma H equal to 0? So I also wrote another force, right? So they have named it as RAX. So I'm going to name it as RAX. So that's the only horizontal force that you see. So RAX is equal to 0. So that's why they are not showing it here at all. I hope you guys are clear. Okay, moment due to load A. So moment, where is the moment? Yeah, here. Sigma MA equal to 0. So what are the moments you have? W into L. So it's a clockwise direction, so positive, minus MA because it's negative direction equal to 0. So what is the value of MA? WL. Got it? So we have found out the reactions on the support. The value of the reactions, RAB is equal to W, MA equal to WL. You guys are clear? Okay, so I think we can write this down. Otherwise, no need, not required. Next class, I will write it in my iPad and I'll show you guys. So it will be clear. Clear, everybody? What is the time? Yeah. Okay. The next is uniformly distributed load. So for a uniformly distributed load, you will have a reaction force here. And you will have a moment. Why? Because it's a fixed support. Got it? So one thing that we need to understand here, we are calculating moment with respect to A. Got it? Even if you take moment with respect to B, we will get the same answer. Okay, so we are taking moment with respect to A. Why we are taking moment with respect to A? Because we are, this MA is unknown. Okay, so moment with respect to A is this. All right. So how do you get, what will be the value here? Sigma V, sigma H, sigma. So sigma V equal to 0. So what is the load for a uniformly? How do you calculate that? W into L is the load. Why? Because there is uniformly distributed load, kilonewton per meter. All right. So for the full length, it's going to be into L and minus plus RAV equal to 0. So this value is WL. And for moment, what is the load? W into L is the load multiplied by perpendicular distance. What is the perpendicular distance here? Every time you have a UDL, take from the center. That means the centroid. So the distance from the, we are calculating with respect to A. So this distance you have to consider. So this distance is nothing but L by 2. Okay, so L by 2 minus MA equal to 0. So what is the value? RAV is equal to WL and MA equal to WL square by 2. Is that clear? These are the basics of how to calculate the reaction forces for a beam having two different types of loads, that is the point load and the uniformly distributed load. Okay, so with this we'll end today's class, and tomorrow's class we will take it in detail for a simply supported beam and a overhanging beam as well. And then we learn how to solve